Hello. Good morning, good afternoon, good evening from wherever the world you are watching us. Welcome to another Fabric Coffee session at Microsoft Fabric Cafe. So just let's kick it off, and I'm gonna open the chat, and in the meantime, you can just say hi, where you're connecting from. How's it going in your side? Is it cold, hot, or what's going on? And so in the meantime, I'm going to just share my slides and jump into today's session. So today, February 15th of 2025, the 23rd of Fabric Coffee session, which is fantastic. Uh, oh, we are at Microsoft Learn community. Like always, you know that, but I'm going to just repeat it for those who doesn't know about Microsoft Learn community. It is a tech community that you can just stay updated with the latest news. You can ask questions and explore certifications with expert guidance. There are learning rooms in different, subjects and in different technologies based on your interest. You can just join one of those learning rooms and you can just get the support from experts and your peers, right? In order to connect to any of those learning rooms, you can just use this short link in the below, aka.ms slash learning rooms, and then just you're gonna choose your learning room based on your interest, especially for the Microsoft Fabric Cafe. So where we are, and that we are only focusing on Microsoft Fabric, and we are providing learning and support to Fabric users in all levels. As you know, we have the weekly sessions, Fabric Coffee sessions, basically to help learners to know more about Microsoft Fabric, in different experiences, from data engineering to data analyst, or data scientists, and so on and so forth. So this forum is for everyone to learn, share, and grow the skills together. And we have fantastic news. So before that, just make sure you're going to follow us on LinkedIn, and if you would like to join our learning room, here is a tiny URL. And that QR code is going to land you on our LinkedIn page. And for all of the upcoming online events or the past sessions, you can just watch them on YouTube with the handle of @Microsoft Fabric Cafe. So there's a code of conduct for sure, and I understand that you're going to adhere to this. I'm not going to repeat them. There's on the screen. Please adhere to these standards in our community. And fantastic news! We will have our very first in-person event in Vancouver, Canada. If you're around in Vancouver, just go and register for this event. Of course, it is going to be a hybrid session, and online attendees also can attend, but it will be at 4 p.m. and March 4th in Vancouver, Canada, in the Microsoft office. So if you're around, I'll see you there. And the registration link, all things are announced in our LinkedIn page. You can just find it there. And for February session, in the past 2 weeks, we had 2 sessions. Actually, one session was rescheduled for March. Brian's session was scheduled to March. I had myself, a session 1st of February, and it is now available, on our LinkedIn. You can just watch it. And for today, we have an amazing speaker with an amazing topic that I really do like about this. Let your fabric work in load testing large amounts of data. So I'm gonna invite Reitse Eskens to the uh, stage. Hey,
Hello
Ricky.
there.
Welcome to Microsoft Fabric Cafe, a
Thank
community
you.
for everyone.
And congratulations on the hybrid event. That's another level.
Yeah, I'm super excited about that one. The online session is good, is awesome. We can have a lot of people from around the world for sure.
Mhm.
But for the in-person session, it has a different kind of energy. That you can just feel. People's and the people's feeling actually, and when they're gonna ask a question, it's gonna be something else, to be honest.
Yep. Oh,
But
absolutely.
yeah, and I'm just hoping that we can have more in-person sessions in other places.
Yep.
But let's see how it's gonna work in the city where I live in Vancouver, and yeah, that's it. Cool. Risti, as I mentioned, I'm super excited about this topic, right? The
Yeah, me as
topic
well.
that you're gonna talk about is maybe one of the hottest questions that comes to us always. That what kind of pressure Fabric is going to tolerate, under the big amount of data, how the scalability is going to work, how we can work with the big data really
Mhm.
on Fabric. So I think these are the questions, uh, you know, uh, that everybody I think has, when they are working in enterprise mode, right? And of course, Fabric is for the enterprise, companies and enterprise solutions, and not for the small ones.
Yep.
So I'm just, I cannot wait to see how we're gonna work on that. But before this, I'm gonna just share some comments. Beautiful day to everyone from Nigeria, Delta State. Nice. We have Ganani. Hi, good morning. This is from yeah, Toronto. Nice. When do you plan to have a hybrid in Toronto, please? Maybe next year, or somewhere in summer. Yeah, we can plan that for sure. And glad to know Meredith is Canadian. Yeah, awesome. Thank you, Ganani. Cool. So I don't want to waste any time. Rista, you can just go forward. I'm gonna share your screen. Greeting from Cologne, Germany. Adrian, welcome to your community. So, Risti, it is yours, guys. Before I hand it over to Risti, please note that you can just add your questions in the chat, and if there is any question related to that topic, I'm gonna just interrupt Risti. I have this permission to just
Yes, you have.
interrupt you right away. But yeah, let's see. Stage is yours, Risti, and yeah, let's go.
Thank you so much, Meredith, and thank you for having me on your session. So, I'm going to talk about Microsoft and Fabric and letting it work and doing all the hard stuff. But before I can dig in everything it can do, we need to talk about some definitions. So the first definition is, what is a large amount of data? Because it's different for everyone. So I've come up with some kind of analogy. Let's start with a small corner shop in an outskirt of a city, and maybe you've got 100 customers every day. For you, it can be a large amount of customers because you need to collect all the cash receipts and you need to transfer every line into your ordering system and your accounting system. And that will be a tedious job. It can ruin a perfectly fine summer evening or winter morning or whatever. And maybe you've got about 2 megabytes of data. For you at that point in time, that can be a lot of data. Suppose business is going well, you're moving to the city center, and from 100 customers every day, you move to 1,000 every day. And they're getting items from your store. You need to automate, I hope, all the receipts into your system. And all of a sudden, instead of 2 megabytes, you're going to 20 or 200 megabytes of data. Your data volume is growing, and all of a sudden, your definition of what a lot of data is changing, because the 2 megabytes, which you thought was a lot, is now not that much anymore. So if you keep going with this, every time your business expands, every time you get more data, you think, oh, this is a lot of data. And what I had, it wasn't that much. So the thing is, what is a large amount of data? And you need to define it. So for this session, for my testing, my definition of a lot of data was around 4 to 6 billion rows in total. And it was around, I think, 600 to 700 gigabytes. Now, for you, maybe that's way more than you're processing on a daily basis. And maybe you think, well, yeah, that's just the morning's work, because the afternoon and the night follows, and I'm processing terabytes of data. I don't know. Thing is, this is my definition of a lot of data, so I had to work with this one. Then we get to the concept of load testing, because how are you going to do load testing? I mean, processing 6 billion rows, it's a fun exercise, and you need to find out what will it tell us. And more importantly, how will it transfer to your own world? That alone, how the results will transfer to your world, is a question I can't answer for you, because I'm not you. But let me take you back a little bit to May 2023, when Fabric dropped at Microsoft Build. At the time that it happened, I was outside watching my son doing some exercises on his racing bike, and my social media exploded with a lot of messages on Fabric. It's a new tool, it's the best thing that ever happened, and we all need to use it. Fine. I need to get my hands on it. So when I got back, I gave him some food, made sure he was all right, and jumped at my laptop to find out what was happening. I activated the trial license, and the good thing was I'm the global admin of my company's tenant, so I can do that. And I started creating some resources, and I went onto the Microsoft Learn site and did the end-to-end tutorials just to find out what it could do. Small side note, those end-to-end tutorials are really good to get your hands on the basics of what Microsoft Fabric can do. So they're really helpful. The only thing that bugged me a little bit, if you will, was that, as usual, it was based on AdventureWorks. And AdventureWorks is a small data set. It's perfectly fine for all those test things, but when you look at the trial capacity you get when you start working with Microsoft Fabric, it's an F64, and that's a lot of compute capacity for a small data set. So that's when I started wondering, well, we've got some customers who are processing more data on a daily basis. So let's find out if I can mimic something, because I'm not going to use their data in a trial stuff and, well, maybe end up in nasty situations. I want it to be clean. So before I move on, a little bit about me. This is stuff about me. I'm doing a lot of stuff in my company. I'm both a data engineer. At times, I'm an architect. I'm a technical consultant. Whatever ticks the box with what I need to do at that point in time. One of the most important things is the QR code on the left side. It will point you to my GitHub repository where you can get the slides, some code, and other cool stuff. Feel free to go there, and if you find something that's broken or not working, just let me know. You can find me on social media as well, LinkedIn, Blue Sky, Mastodon, usually with the 2-meter DBA tag, because I'm Dutch, and which means generally we're quite tall. Also, I'm doing some unspeakable things to F2's queues since 2023, when I started load testing them for science. It's a little bit of a gimmick that one of my co-MVPs, Alexander Arvidsson, came up with, and it kind of stuck. Now, before I'm getting into all the data side of things, I need to make something clear about the way I work with load testing, because I'm coming from a SQL world. And when I'm in a SQL world, things can be quite simple because I'm starting my query, and when I want to measure my performance, I'm looking at disk I/O, I'm looking at memory usage, I'm looking at CPU usage, and it's not that hard to get all those metrics together and find out if my query is way too I/O heavy, or maybe doing too much on the CPU, or it's hogging memory like mad and pushing everything else out of memory. But I can find out, I've got execution plans, and I can do my stuff with it. Thing is, in Fabric, a lot of things are not only different, but sometimes very different. The data processing is run on clusters, and the only control I have over them is by scaling my capacity up or down. That's about it. I can't really control much more of that. Yeah, I can do some stuff on workspaces and create other things, but in the end, it's not everything I can do. Then there's the concept of bursting and smoothing, and I'll get into that more later. But it also it means the process can go faster or slow down or do other horrible stuff, which we'll find out about later. But there's a lot of stuff happening in the backend. So when you want to get to grips with all this, you need to learn the Microsoft Fabric Capacity app, metrics app. But we also need something like data we need to work with. So yeah, there's a lot of stuff happening, but let's get to the monitoring part first. The Fabric Capacity Metrics app. It's a horrible word. I'm sorry. I keep stumbling over it. The metrics app. Let's put it like that. It's going to show you all kinds of things, but the main thing you need to be aware of are capacity units. So let's start. Let's dig into those capacity units and start with the basic. 1 second of work is 1 capacity unit. So far, so good. All right. So when you've deployed an F2 capacity, this means you've got 2 capacity units every second. Not too hard so far. So the capacity units are evaluated in blocks or time spans of 30 seconds, which means that when you've got an F2, you got 2 times 30 seconds. 2 times 30 is 60 capacity units. This is a number you need to have in the back of your mind because, and here's my coffee, this number will come back in the metrics app. So when you're having an F64, it's like the same calculation. 64 times 30 is 1920 capacity units. Cool. These numbers are numbers you just need to keep them in the back of your head when you're looking at stuff. So let's dig into the metrics app and see the first thing that comes up. It's the multi-metric ribbon chart. It shows you the total consumption based on somewhat daily, hourly basis. The good thing is you get an overview of everything that's happening and if stuff is peaking or not. The thing that I'm personally missing is something on the y-axis showing me numbers. Because is this a lot? Is this nothing? So I need to hover over and find the metrics values. It gives you a basic indication if things are running heavily or if it's a little quiet. So when you hover over this, you get a tooltip which will show you the stuff that's happening, how many capacity units a certain resource in total has been using. So in this case, my Synapse notebook, and this can be more than one notebook, has been using 495,720 capacity units on that specific day, Tuesday the 2nd. So then you can find out what's the total number of capacity units I've got for a complete day, and is this a lot or is this just peanuts? On the right side, there's a graph that will give you way more information because this one will show you, for instance, here in this screenshot, the utilization. It will show you the percentage of your total capacity that has been used with background processors, interactive, background processors that are non-billable, interactive stuff, and stuff like that. It will all come together and you get a percentage from 0 to 100 or sometimes a lot over 100%. So this will give you, these two graphs will give you a first indication of what's happening. Now there's something else, which is called utilization and throttling. So the minute you are going over the limit that you're allowed to go, if it's less than 10 minutes, throttling will not happen. It'll be fine. When it's more than 10 minutes but less than 60, you get some interactive throttling. Over 60 minutes, but on 24 hours, interactive jobs will get rejected, which means users will get error messages. And when you're over the threshold of what you're allowed to use for longer than 24 hours, everything will be rejected. You'll be swamped with error messages, and people will stand at your desk asking what's happening. So you need to be in control of what's happening. So one thing you can do is click on the drill through button to get to some time point details, which will help you find out what was happening at that certain point in time. But let me go back a little bit, because when you're looking at this graph, there we go, you can see some holes. Like there wasn't any measurement. So I made a typo in the slide I just saw. It says don't slide but zoom. It should say don't slide but filter. So when I'm using my slider at the bottom here, you can see I'm kind of zooming in on a day, and you can see a lot of gaps opening up. This is not because the capacity metrics app wasn't recording the data. It's just that Power BI has a maximum number of data points it can show you on a graph. When I'm using the slider, I'm only zooming in on the graph. I'm not reloading. So when I'm using a filter you can find on the right side, this will happen. You can see that my slider is way shorter and all my data is there. So the data is actually being recorded. It's just how you work with this capacity metrics app that will determine how it's being shown. So I learned this trick only last week because the documentation on this one is running a little behind. But this was, for me, this was a golden moment. Like, that's how that works, and that's why I can't find all my metrics, and that's why now I understand. There was the second one as well, second pro tip. Because when you're going to dig into the time point details, what you often see is this. I've got my details set from 11:17:30 to 11:18:00, like a time point of 30 seconds. Again, working with the 30 seconds time frame of the capacity. But you'll see right here that there are different timestamps, 11:14, 13:12, 11:10. And when you're just loading this graph, you won't see why. Why are these here? So what you need to do is go into the table settings and add these two columns, smoothing start and smoothing end. Because these two columns will show you why they're shown at that point in time. It's because the smoothing started at 11:17 and ends at 11:22. And 11:17 is the starting point of my time frame where I'm looking at. Adding these two columns will help you massively in understanding why your capacity is being loaded that heavily. So, large amounts of data, in the end, is just a matter of perspective. When you're using Microsoft Fabric, you can learn a lot of new skills. And one of the skills you need to learn, because it is a skill, is measuring Fabric capacity usage. Before I'm moving on, Merda, do you have any questions in the chat?
No questions so far.
Cool.
Yeah.
So that either means that people think, ramble on, or I've been very clear. So let's move from theory to actual data, because I need to have some data to to do my load testing with. So what I did, I found the TPCH dataset, and you need to create the tooling yourself. Getting this tool to work is a little bit of a fiddle because you need Visual Studio, in my case, to compile the source code. And then you have to run it to create the data files. The tables are a third normal form schema. I'll show you in a minute. And you can create data sets from, well, megabytes to petabytes if you want. Just tell it like this on the command line what you want it to create, what you want the tool to create for you, and it's done. It's like it will run. There's one thing I want to highlight, and that's this one, the -v flag, verbose. Then it will show you on screen what it's doing. The computer I was running this binary on wasn't actually the newest, so it wasn't super fast. And at some point I thought, well, it crashed. It's not doing anything anymore. So I broke it off, and then it told me, yeah, I was doing this, and now you killed it off, so you need to start again. By putting it in verbose mode, it will keep telling you, I'm doing this, I'm doing this, I'm doing this. You can check on its progress. It is not a fast process. It's not like it's done in 5 minutes. I think my computer took around 24 hours to create all the data files. It's just what it is. Just let it run. There's some flags there you can check out for yourself and create your data set. What you can also do is, based on the set you've created, create a kind of update statement, which means it will generate some files based on the files you've got with updates and deletes. So you can kind of sort of mimic an old P system. Maybe it's handy for you, maybe not. I just want to show you there's the option. So the database schema looks like this. And the funny thing is, at the bottom here, you can see the region table, which is 3 or 4 columns. It's got the least amount of rows as well. So every table that has more columns will have more rows as well. So it's like almost it's not a pyramid scheme, but it feels a bit like a pyramid. More columns means more rows, means more data that will get into it. Now, I once did this session in a cinema, and that was about the only time people could actually read what was on here. This is just a screenshot to show you the files that I created from a few bytes to, let's do a quick look, about 75 gigabytes for the line items. There's a lot of files there. The TPCH dataset is free. It contains nonsense data, so you can share it with whoever you want. A little quicker to get running, but it's very, very flexible, as long as you've got the disk storage to store all the data. Now, there are a few ways to ingest data into Fabric, and I've purposely left out the Fabric SQL database for now, because I'm still trying out some stuff. And I'm having some conversations with Microsoft on some findings I've got, and it just doesn't feel fair to include it right here with everything, with all the other load tests. It will get here in here eventually, but for now I've decided to skip it. If you want to load data into Fabric, you can either use a Fabric notebook, but you can only load data with a Fabric notebook into a Fabric lakehouse. You can't load data from a Fabric notebook in a Fabric warehouse. If you want to load your data in a warehouse, you either need the Dataflow Gen 2 or the pipeline experience with the copy data stuff. Which is cool, but the question is and will remain, which is the best fit for you? So in general, I'd like to say that getting data from sources is done the easiest with a pipeline, copy data activity, whatever. It's where they excel, just reading, writing, done. It also supports a lot of connectors, and it integrates quite nicely with Key Vault. You can try and do it with a notebook as well, but it's just a little bit harder. But whenever you need to go modifying data, joining tables, etc., you can use a pipeline, but it might be easier or more efficient to use a notebook. Maybe it is. Let's see in a few slides what's happening. If you're coming from SSCS, mapping data flows in ADF, or you've been using data flows within Power BI, then the Gen 2 can be your method of choice. In the end, it's just like a balance of choosing the right tool for the job and finding out what fits your use case and something some people seem to skip. What fits your I want to say level of knowledge, but that's the wrong one. What fits your skill set? Are you fluent in SQL? Are you fluent in Spark, PySpark? Or are you just most happy when you've got a GUI? Make the choice based on that. It's fine. Um, Also, one thing to think about is when you're creating something and you're the only one that knows about this technique. Suppose you're creating a lot of notebooks and you're the only one in the company who can write PySpark. You're always on call because when stuff breaks, people will call you. All right, let's start loading stuff in. Um, let's start with the pipeline. Or the options we've got. We've got pipelines, notebooks, and data flows into. You can use the pipeline to get data from your source and write it to either like a lakehouse or warehouse, doesn't matter. So let's get the first one going. Let's go with the pipeline. The pipeline is quite easy going because this is what I created. It was just a default pipeline. I want to copy files to my lakehouse, which means I've got my source, which are some files. I've got my destination, which is my lakehouse. And I'm almost done. I've kept all the settings to auto. That may or may not be the best option. This is what I did. You can tinker with them a little bit to minimize usage of Spark cores or just let it rip the way Fabric thinks is best. The F64 took 33 minutes to get from using 638 parallel copies to get all my data from CSV into my lakehouse. Cool. So let's see what the F2 did. It took 32 minutes and 39 seconds, which is kind of sort of almost the same. Same amount of parallel copies, so both had a balanced throughput. Yeah, it's about the same. So this specific copy activity, it doesn't matter if you've got an F2 or an F64. You won't see any difference here in the timing. The thing is, when I was running my F2, this job alone took 73% of my available capacity, which means I've got 25% left for anything else what should run at that point in time. Now then things might get a little different because I won't be doing just this. There will be a lot of other stuff happening. So you need to get this kind of system, this kind of knowledge in your system. What do these numbers mean? Because yeah, it's running on 73%. If this is all that's running, fine. If you need to do more, you might be in trouble. So the F64, I ran it 10 times to try out some things. You can see around the same number of capacity units used. But because the F64 is 32 times stronger than the F2, it was just like, yeah, 22%. Got anything else to do for me? Because I'm bored. Come on, let's do stuff. So you can see some details in here as well about what's happening. Again, the calculation here for you to show you what's actually happening in the system. So for this simple copy data pipeline, the F2 was on 73%, the F64 on 2.2. What else is going on? Because this is not the only stuff we're doing. We're not just copying stuff into Fabric and then doing nothing. Murdo, did you have a question?
No question there, but I've got question myself.
Okay, go ahead.
The percentage that you're showing now is only for copying the files, right?
Yes.
Just uploading actually the files into your Lakehouse file, right?
Mm-hmm. Yep.
Okay. And So, at the end of maybe or in the middle, we can just just keep in mind, show us, is there any guidance that's about amount of data that we have, which actually capacity of which capacity of fabric is suitable for that, that we are not overestimating for our capacity. Maybe I'm just jumping ahead in your topic, but in
You
your
are, but that's
presentation.
perfectly fine. That's you're exactly your question is pointing to something I'm working towards in my session. So
Awesome.
excellent
Yeah.
question.
Yeah,
Those are the
cool.
best ones.
Yeah, keep going. But I just wanted to make sure that we are I'm understanding well that it is only for copying the file,
Yep.
and we have
Yep.
not processed that yet.
Nope.
Yeah,
Nothing happened to the files.
cool. Yeah, please. Yeah.
All right. Let's go. Let's do some stuff with our data because, as you rightfully said, I just copied the files in, which means I've got my files in my lakehouse as the CSV files. But working with CSVs is like, yeah, not ideal. Let's put it like that. So I want to transfer my CSV files into Parquet files, Delta format, and nicely put as tables in my lakehouse where I can leverage all the power. So I need to transfer them. So what I'm doing here in this script is I'm reading from my CSV files. I'm creating my schema, telling it this is the column name, this is the data type that's in there. I'm going to read CSV files, so it knows it's a CSV file from a folder path. It does not have a header, which can be painful when you find out when you're loading stuff. It is allowed to drop malformed rows. In this case, it's fine. I didn't have the time or energy to deal with errors somewhere in 500 million rows. It's got a pipe sign as a separator. My schema has been defined here, and I'm going to override it. So I'm going to load all the stuff in, and I've defined the table name. So when I'm running this, in effect, I'm just reading CSV, writing out Delta Parquet. So the first one I tried out didn't have all that many rows. 120 million rows, not that many. It took 2 minutes and 28 seconds on an F2. So the F2 was just running through it. Now you need to keep in mind that there were no data modifications. Nothing was happening there. It's just reading, writing, like a copy, but changing the data, the file type essentially. So then I thought, well, the F64, 32 times stronger. Will it be 32 times faster? Because we've got a little bit of a delay to the audience, I can't wait. I can't ask you directly the questions and wait on your answer because it would almost take a minute. Thing is, on the F64, it was about twice as fast. 1 minute, 13 seconds. Just churning through all the rows, reading them, writing them. Then again, this is 120 million rows, 120 gigabytes, something like that. Let's make it a little bit more interesting. Let's go to a larger file. This is the biggest one I've got, line item. This is around 500 gigabytes of data, lots of columns. Same idea. So defining the schema, allowing it to drop malformed stuff and writing it into a table. Now here you can see a difference because the F2 did have a little bit more issues with it. It took quite some time. It took 2 hours and 4 minutes to process all the data, 4.2 billion rows. It's a lot, I know. And it's allowed to take quite a lot of time. Fine. But now the question is, what can the F64 do with it? Because it's got more cores, it can parallelize more. How much faster will it be? I did the exact same thing on the F64 and it finished in 7 minutes and 46 seconds. Now we're talking speed and differences. Now you can see where the F64 can actually do a lot of stuff because it's got way, way more compute power. So it can churn through all the data much faster and do all the stuff. This is cool. So how many capacity units did it take? Well, my F2 was almost at its limit. It took 56 capacity units to get through all that data, which meant it was almost at 100%. And this also shows you that when it's almost at 100%, it starts to do other stuff to not completely eat up the entire capacity, but maybe smooth out the load a little bit, smooth out the load a little bit more, and make sure you get to a safe result without killing off the capacity, but it takes more time. So one of the key things you need to remember, and I'll reiterate at the end, performance can cost money. Or put differently, how much money are you prepared to invest for how much for a quicker solution? Or do you need it? Something you need to think about. Same thing for my F64. You can see that the total capacity units used here is 293. So the F2 stopped at using 56 capacity units, while my F64 had way more room for more capacity stuff and went to 293, using more compute power, working faster through the load. You can also see that my interactive delays were almost hitting 100%, which means I was close to the point where on my F2, I was close to the point where it would start to delay me and tell me, slow down, don't do this right now, just wait a little. On my F64, yeah, 15%, it wasn't bothered. So this was the simple changing the file type, if you will, from CSV to Parquet. That's not all we're doing. We're usually fooling around with the data and, well, let's just create a table with some extra columns. And not only creating extra columns, because this is quite an easy function. I just want a year, quarter, and a month column added to my table. I'm also going to do some partitioning because I want my data partitioned in year and quarter, which means different folders are created on my OneLake. So when I'm running this on an F2, it's processing 16 gigabytes of data, 773 million rows, and it takes around 18 minutes. 18, not 80, 18. Cool. Not exceptionally fast, but maybe fast enough. So going to the F64, I was wondering what will happen there. Well, it went through in 8 minutes. That's a lot faster because, again, it can process data much faster. So let's talk about joining tables.
Reitse, before you move on to the next one, there's a question that maybe it's going to be others' question as well. The performance testing that you're doing is a single task, right?
Yes.
And
Yep.
of course, we have for a capacity, we are not alone, working on that capacity, and we have other workloads. Adrian is actually asking, how does the performance change when there are other workloads on the machines?
That is a very good question. It is something that's difficult for me to test when I'm on my own. So I'm going to move to my regular work where we're in projects with multiple people at the same time. And where we found that when you've got an F2 capacity and you try to work with two people on the same project, F2 just keels over. It's very hard to work with two people on the same project with an F2. And F4 if you're lucky. F8 is the basic if you're heavily developing.
No.
That's what I've found so far. When you're also processing silly stuff like I'm doing actually in this screenshot, an F8 might get all the compute available, run it, and the other developer that wants to do some work is left hanging with, I'm waiting for some capacity to free up and start a Spark session or whatever. Again, check your Fabric Metrics capacity app. Also, when you're starting a project, my how do you say it? Um, I just want to advise you always start with the free trial. It'll give you 60 days of F64 capacity where you can build whatever you want and you can get a feel of how much capacity you need. Right now, at my day job, we're in a project where we're doing exactly that. We're running on the trial capacity, building stuff, and constantly trying to find out how much capacity are we using, and we're bouncing between an F8 and an F16. So that's something you need to find out for yourself. But start on the trial capacity and then find out how much capacity you're going to need. But F2, F4 are you can get a lot of performance out of them, but when you're working on a project with multiple people, I think you quickly move to an F8, at least. I hope that answers the question.
Yeah. Yeah, please go on.
Okay. So in this scenario, I'm joining two large tables, the biggest one I've got. And on my F2, it took 2 hours and 16 minutes. Again, quite some time, but again, it had to join the tables, find out all the links, and partition it out by year and quarter. Then came the question, what will it do on the F64? Now, the thing in the screenshot is, at first I thought, oh, it's really fast because it finished in 2 minutes 39 seconds. No, that was the time it took the Apache Spark session to get ready for me. The actual command was executed in 14 minutes and 51 seconds. Still quite an improvement on what the F2 did, but yeah, well, maybe I expected a little bit more. On the other hand, these are silly amounts of data that should not be processed on a daily basis, and was just trying to find out what happens. So how many capacity units did it take? Well, not that many actually. It just took 15. So in this case, you can see that the capacity units used wasn't all that high, and still it took quite a long time because it couldn't parallelize the entire process. So it had to. It's like running a large database on your old 4-core laptop, for instance. At some point, it just can't go any faster, even though it might not require all that much capacity. It's just getting stuck, which is nothing bad towards the F2 capacity. It's just the way it is. So then I thought, let's try do something with the pipeline or the data flow Gen 2. Again, a typo in my slide, my apology. So I tried to copy raw orders and line items together, join them and see what happens. So I did this, and then you've got an option to run it. And after 2 hours, it told me it failed. Why? Because I ran out of my capacity. Now, how bad did I run out of my capacity? Was it really, really that bad? Yeah, this is an intermediate screenshot where I was at 22,000% of my capacity usage. So at some point in time, these data flow Gen 2 thingies can actually hurt you very, very bad. It will keep adding stuff, and it takes quite some time to clean it up again. Then I heard something from Microsoft Fabric where you can see it as some kind of a turbo button. It's called fast copy. If you're in the development environment of Microsoft Fabric, you can find it at scale, and you can put a check mark in the checkbox for allowed use of fast copy connectors. And you can even tell it require fast copy. Doesn't always work. It will have a massive improvement. Because without a fast copy, everything failed. With it, it started to succeed. And you can also see the most important one here. Without fast copy, it required 394 capacity units, which should work on the F64 but didn't. But here, only 78 were necessary. So it's like, whoa, big improvement. Now they're working on supporting all kinds of data sources. It's a little limited for now, but they're trying to get everything on parity with the Azure ADF experience within Fabric. They're working hard on it, and I think this is a really powerful way to ingest and copy data and make sure it's all joined together. Now, people who know me know that I'm a data engineer and not a reporting developer. So, yeah, are you seriously going into Power BI? Well, I thought let's try something. So I created a smaller semantic model because I still understand how to do that because it's like a default star schema with a effect and a snowflake dimension. Not the best one. Cool. I created something. So this was the first message I got. I couldn't load data for this visual, so I may or may not have just dragged the entire effect table onto my canvas, which may or may not have been the best idea. And then I got a message that I've reached my capacity. And when you click on the link, this is the message you get. It's like, ooh, this is not good. But at least I know where I went wrong. I exceeded my limits. And not by a little bit. This was the first screenshot I took where I went over 2000%. And after some time, you can see that my overage kept growing and growing and growing somewhere to the 40,000% mark. What you can also see here is that the overusage builds up quite fast, but the burn down takes way longer, about 3 times longer. So this was not good. And there are a few ways to get out of this situation. I'm not saying there are good ways, but there are a few ways. The first thing you can do is add capacity units. In other words, scale up. This is a screenshot I took when it was still burning down on my F2 capacity. And when I scaled up to F8, you can see that my expected minutes to burn down went down from 7 minutes to only 1.7 minute. Fine, it's something calculated. But you can see it increases speed. The other trick you can do is pause your capacity. What happens is that all the capacity units you've used from the future, which is like the bursting system where you can borrow from the future to improve your speed right now, it will be immediately added to your Azure bill. So pause your capacity, you pay some or more extra money, restart your capacity, and everything is reset to 0. It can be a solution. The best thing, though, is just to get a good feel of what's happening. Make sure you're in control of your capacities and are able to prepare for heavier loads. Because there are APIs available where you can scale your capacity up and down. So the thing we're looking at right now is leveraging those APIs within our ETL process. When we know, we need when we need a lot more capacity, we're gonna kick off a scale up where we're going from say F8 to F32, do the heavy work. After that, scale down again and move on to prevent these heavy overloads. It won't be perfect, it won't be watertight, but it should help. So, getting everything together. Looking at my notebook, because this was the most important part of Fabric. You can see that time-wise, the F2 took around 5 hours for my entire process, and F64 65 minutes. You can also see that difference here. It doesn't really make that much of a difference when you're downloading the customers, processing them. Yeah, it does make a little bit of a difference. This one, the light items, this is where stuff gets interesting because it's 17 times faster. This is an interesting one as well with the big order lines, which meant joining everything together. The thing I have found, and which will answer your question earlier, Mehrdad, is the data volume itself. It doesn't really make that much of a difference. The differences you will find is what you're doing with them, because the more complex the operations are on your data, the more it needs to calculate stuff, join stuff, how do you call it? Change data types, get all kinds of interaction with your data to create new columns or whatever. Whenever it needs to work hard, compute stuff, that's where you're going to find the big differences. And if it's just straight line work, and F2 might be able to do everything for you. But the moment you're going to build a star schema and get do the interesting stuff to create extra value from your data, you're going to need a lot of extra compute capacity.
I see.
Okay, cool. Now, one of the final slides I wanted to show you are the comparisons between the SKUs and everything that's running on them. So when you've got an F2, the cheapest one, you get 2 capacity units, a quarter of a Power BI core, however they're going to do that. You get 4 Spark cores. So you get some parallelism, but very little. This graph, everything doubles whenever you move up 1 step. So in F4, everything goes by times 2, and again times 2 when you go to the F8, F16, etc. The maximum one is an F2048, which will be very, very bad for your credit card, but will give you an enormous amount of power. So you need to find out, how much do I need? Again, I can't stress it enough. Make sure you get in tune with your Fabric Capacity Metrics app and find out what all your stuff is doing. Yes, you have a question, I think.
Yeah, actually, I was going to ask about again, differences between the capacities, right? Uh, as you mentioned, sometimes the amount of data is not that important, right? And how long we expect a process of for data engineering, or for the data transformation is going to take us, matters to us, right? For example, it's going to take 65 minutes in your F64, or in your F2 capacity, it actually took 5 hours, right?
Yeah, yeah,
So sometimes time matters, right?
yeah.
But in some cases, just let's back to your example, when you were loading with Gen 2, right? With data flow Gen 2, right?
Yeah,
And it failed after 2 hours without having the fast copy, right?
yeah.
And we all know, the fast copy is only available in F64, right? And not in the other capacities, if I'm not mistaken. The fast copy is available in other
No, this fast
capacities.
copy should be available in F2 as well. As far as I know, it's not gated between the F64.
Yeah, I from what I remember, I have to check it, but as far as I know, the F64 only has the fast copy feature. So,
Oh,
however, I just wanted to mention about 3 items with that regard.
yeah,
When we want to choose, a capacity, we have to just consider lots of things, right? One of them is the workload of our data. The other one, for example, one issue that I faced, a couple of months ago. I'm not sure it is resolved or not, but the private link from data lake is was only available in F64, right?
mhm,
And not available in the lower capacities. There are some limitations that maybe is pushing businesses and companies to go with the higher capacity. The more features are going to be available there. It is the business. We are not
yeah,
talking about that one,
yeah,
but about the workload, it was interesting that even for your semantic model, there was some limitation or exceeding your capacity. And you were not successful to even test it, right?
yeah,
Just load it to your Power BI and see what's going on with that. To 4 billion records.
yeah,
So of course, maybe I'm just telling, for those kind of scenarios, we need to just look at the design of of the records. Are we really going to analyze 2 million records or 4 billion records at the same time. What we are going to do that, maybe it is required, with the bigger enterprise companies or banks or some organization like that they need it. But of course, uh, there are some workarounds to just aggregate the data or something like that. What do you think about this? Is there any suggestion when we are running out of capacity for loading the data into semantic model? What was your finding about that one?
My finding in my testing work was that I was just doing very stupid things. So I'll be honest with that. I tried to get way too much data into the semantic model and to the Power BI report. In general, what you need to do is just pre-aggregate things. So you're not going to analyze 2 million rows on a Power BI report individually. You're going to aggregate it in some way. So make sure the aggregations are done on the in your lakehouse or warehouse or wherever you want to store the data, and then load it into Power BI or filter as early as you can. So don't do it. Do as little as possible on your Power BI Power BI report, because it won't be able to handle. No matter if you're doing a direct lake or a direct query, it'll have a hard time. So make sure as little data as possible flows to your Power BI report for the people who want to do the analysis. That's I think the main thing.
Yeah, and guys, we're online. Just write it for us if you have faced, with kind of issues, with loading the data. And yeah, just tell us the experiences, your experiences. Actually, it's going to help, the community a lot, to how to deal with this kind of, difficulties. And this session is being recorded, and it
Yep.
will be available afterward, of course. And if you're watching this video or rewatching this video, just write it for us, and let's see how we can just help each other on this kind of
Yeah.
difficulties. Yeah, I know it's good. That's put the pressure on this guy and to see what's going on. Okay, guys, open floor. If you have any question, if you have any comments, you can add in the chat box on both LinkedIn and YouTube. If there's nothing, I think we can move forward with our interesting part
Oh,
on
let's have some fun.
riddles. Yeah.
Yeah. So I've
I
come
don't
up.
see any question. Rich, sorry,
Oh,
interrupt
yeah.
you. I don't see any question with that regard. However, we keep an eye open on our chats, but if anything comes up. But for the riddle, yeah.
All right. Let's go with the first one. Let's see who paid attention. So I think we need to give it a little some time because there's delay in the connection and stuff like that. So
Yeah, there are some delays from LinkedIn always, but let's see. So where can I find out how which processes are smooth and are adding to my current capacity usage? Cool, guys.
there's some answers coming
Let's
in.
see who was listening
Oh
to the lecture.
no! I'm going to break some rules here because this is an answer that will you get 2 points for this one if you got it fully correct, and if you got one of those parts of the answer correct, you get 1 point. So I'm going to give you some extra work as well, Matt. I'm sorry. If you want to handle it in a different way, it's fine as well. It's just a kind of sort of 2 point answer.
That's fine. Let's firstly wait if anyone. Adrian is saying capacity utilization.
Yeah, typing is hard. I know. I mean, I've seen a lot of typos in my slides, and I've gone over them a lot of times. So No.
Ganani says Microsoft Fabric Capacity Metrics app.
Mm-hmm.
And Papa says Fabric Metrics app.
So I'm just waiting on your signal to reveal the answer.
Yeah, let's go to reveal the answer.
So it's the Fabric Capacity Metrics app, but you need to get into the time point details to find out what's adding to my current capacity usage. You need to
Okay,
get
and
into those time
so
point details
it
because there you
goes
can see the
to
smooth processes that are adding to it as well.
yeah. So it goes to Ganani, right?
Yes.
Ganani, you were one of the winners before, but
We.
just call send us a message on LinkedIn or on Microsoft Teams. So we can have another one. Right, it?
All right. So this is a little bit of a silly one because I thought we can be all serious, but it's early in the morning, and let's go out with a silly one. You can also call it a little bit of a dad joke. Maybe it's because it's later in the evening right here where I live, so it's
Why was the computer cold at the office? Cool. Any answer for this question, guys?
let's see if people get this one.
Yeah. I'm also thinking about this. Not enough data. Yeah. Adrian says not enough data.
Oh, that one. Can I tell a little anecdote whilst people are sending in the answers? So about 15 years ago, when I just started at my current company, one of my coworkers had to do some heavy work on a client server, and the server was getting really busy. And at some point, my coworker lost connection to the server, so he called the client and said, "I want to do work on your stuff, but I can't connect to the server anymore." And they said, "Well, maybe you need to wait a little." And they hung up, and then he thought, "What's happening? Why?" So the next day, the client called back and said, "Yeah, well, we had a small issue in our server room because the server you were working on caught fire."
Good.
So I had been hammering the poor machine with a lot of commands where I had to do a lot of stuff. I don't know, I can't remember what it was doing, but at some point it overheated and caught fire. So yeah, well, not enough data might be a way to get a computer cold, but in this case, it's overheated because I had to
Yeah.
do too much.
Yeah. Ganani says because there was no coffee in the cafe. Mhm. Yeah. Seriously speaking, workloads do not run in the early morning.
Oh well, we've got a lot of
Yeah.
nightly loads that will usually extend to early morning, so maybe can be.
Raphael, because it left its windows open, right? And enter disconnect servers in the
Oh
middle.
yes, I need to do some vacuum. I don't know what this plug is for. Let's plug it out and do something and plug something else in. We've had that one before as well. Drop the
Yeah,
connection. Uh-oh.
yeah. Most of the hard things are happening during the night.
Yep.
Yeah, I think we can reveal the answer for this one, Ritzy, because it it had its window open. Oh, Raphael.
Yep, you want that one.
Cool. Raphael, just send us a message, in our LinkedIn page. And you can claim your uh exam voucher. So, Ritzy, if there's anything to add, let's do. If not, I can just take it over and go to my slides.
Let me see.
And
No, I've presented everything I wanted to do for today.
awesome, awesome.
So,
Thank you very much,
no,
Ritzy. It was really interesting.
thank you.
That sometimes we really need to test the fabric and whatever that we are working with at a scale, right? And which I really love it. So I'm gonna share my screen. Thank you very much, Ritzy. So for today's session, it is done. For those who joined late or who couldn't make it, or if you want to rewatch this session, it is going to be available right away in an our YouTube channel. Yeah, thanks everyone for joining. Just stay tuned for the next session with our another speaker, Garrett. And again, for those who are around in Vancouver or even around the world, you can just join us online if that time actually fits for you. Because at 4 p.m. in Pacific time, most of the guys are sleeping, in the adult in other part of the world. But however, if you're around in Vancouver, just show your RSVP with us, and I'm gonna just wait for you guys there. And again, thanks for attending. Stay tuned. Follow us on LinkedIn and YouTube, and also feel free to join the learning room. There are some comments from Ganani. I do work on genomics where there are millions of rows. And thank you for a nice workshop for loading balancing. Thank you for
Thank you.
joining. And Edwin, thanks. Enjoy the weekend. Cool. If there is anything to add, let's see. Feel free. If not, we can just wrap it up. And from Papa, that was a very interesting presentation. Thank you. Thank
Thank
you.
you.
And
Yeah, that's about it for me as well. Thank you so much for having me. Thank you for attending and your feedback. And well, if you have any questions, you know where to find me.
for sure. Cool, guys. So here in Canada is a long weekend. We are going to be ready for this long weekend, and we're already
Enjoy the
ready.
weekend.
Monday is family day in Canada. So yeah, guys, enjoy your weekend, and thanks everyone for joining. And I will see you next week in the next Fabric Coffee session. And Ritzy, thank you very much for your attendance. It was really interesting topic. I did love it, and I hope and I'm sure others did also. And if you guys have any question, you can just ping maybe or tag Ritzy on our LinkedIn under the page actually the page post. And yeah, and until the next time, see you.